All right, let's get to the calculator for these. So the TIs can perform these tests, which is great news, but it can only do it for standard deviations. So you'll see it when we get to the menu, but you have to put in standard deviation. You can't put in variance. So you just have to take the square root of the variance. The way you find this, it's in stat tests and is a 2-sample F test. So pretty easy to find. All right, so let's check this one out. A quality control inspector believes that the candy making machines on assembly line A are not adjusted properly. She thinks that the variance in the sizes of candy produced by line A is greater than the variance in the sizes produced by line B. So we have a random sample from each assembly line. Line A has a sample variance, and that's going to be important, of 1.45, and line B has a sample variance of 0.47. Using a 0.01 level of significance, perform a hypothesis test to test the inspector's claim. Assume that they're both normally distributed. So we want to define our population 1. Population 1 is going to be line A. And then population 2 is line B. So our null hypothesis, let's see, what are we trying to see? She thinks the variances and sizes of A is greater than the variance in B. So she says that line A is greater than variance in line B. So our null hypothesis is going to be the opposite of that. All right, we are doing an F test, or an F distribution at alpha is 0.01. And now we're going to let the calculator do step 3. Now let me write down what you're doing in the calculator because I don't have that. I don't have a calculator on my Chromebook. So you're going to go to stat, test, and it is a 2-sample F test. And the first thing you need to pick is that you have stats, you don't have data. So the first thing the calculator is going to ask is Sx1, that's the standard deviation of x1. Remember, we have sample variance, so we need to take the square root of that. So square root of 1.45, and you can put it in the calculator directly like this, no problem. Sample size is 20, and then ask for the standard deviation of the second sample. Remember, we have variance, so you're going to have to take the square root of that. Just type it in the calculator just like that. Sample size is 20, and let's see. It is a right tail test, so you're going to need to pick that one. Remember, that always comes from your alternative hypothesis, which one you're doing. Go ahead and hit calculate, and the calculator will tell you something delightful like p-value so that we can decide what to do with this. So let's see. My calculator says p equals 0.0090. So we compare that to our alpha. P is less than alpha, so we are going to decide to reject the null hypothesis. We are not done. You have to write your interpretation. So I think I can squeeze that in here. So we're going to say at the 0.01 level of significance, the data supports that the variance in candy size is greater on line A than on line B. Okay, so same steps as always, and the calculator does a really great job of getting us through that. So let's check out this last example here. A professor claims that the variance of test scores on 2 different versions of the exam are not equal. So he's got a sample of scores on each version. We've got the information there. Assuming they're both normally distributed, conduct a hypothesis test, use a 0.05 level of significance. All right, so let's start. It's always a good idea to define your population. So population 1 is going to be version A of the test, and population 2 is going to be version B. And we're going to write our null and alternative hypothesis. Let's see. he is claiming that they are not equal. He's not saying which one's bigger, so we are going to say that these two variances are not equal. So our null hypothesis is that they are equal. So this is a two-tailed test. So this is going to be an F test or an F distribution at 0.05. And then you're going to go to your calculator. You're going to go to stat, test, two sample F test. And again, you have stats, not data. So it's going to ask you for SX1, that's the standard deviation. We have sample variance, so you need to take the square root of that. Be super careful when you're doing your homework because sometimes they will give you sample standard deviation and you don't have to take the square root. So just pay attention. N1 is going to be 20. Sample standard deviation of the second population. We have variance, so we have to take the square root of 3.3. That is also 20. And then this time you're going to choose the not equal one. Make sure that's highlighted before you hit calculate. And calculator is going to give you a p-value of 0.7616, which is clearly way bigger than alpha. So we are going to fail to reject our null hypothesis. Okay, and we want to interpret this. So at the 0.05 level of significance, there is not sufficient evidence to say that scores on the different versions have different variances. Obviously, you'd want to write that sentence down. I'm a little short on space, so I won't. So those are F tests for sample variances.